All right, here we go. We are into some of the final videos of this review. We know that our final is due before you start your test, so that day of those finals, and it is worth 10 points on your final exam grade. So right now we've left off, we should be starting on number 70. No, 71. My bad. Okay, so if I look at 71, Teresa placed 35 yeast cells in a 50% solution of dextrose and measured the amount of carbon dioxide released. After analyzing her data, she determined that the yeast cells were tripling every hour. What equation can be used to find the number of cells present at the end of each hours? Okay, so a few things I'm noticing that we're in the exponential part of it, so I know that my equation is going to follow y equals ab to the x power. I know that a is my initial value and b is my growth rate or decay rate. So when I look, where does my stuff start? What's my starting initial value? 35 yeast cells. This 50% solution, I'm not sure if that's going to work in it. Like, we're going to keep looking on it. I'm going to see what's going on. And then we also have, ooh, they're hiding it. She determined that it was tripling every hour. Okay, so I also notice here that's giving me H hours, and it mentions hours here. So I'm thinking this 50% solution is extra information, and the tripling, the 3, or 3 times it, 300% is what's actually important. So if I put those together, I have y equals 35 to start times 3, and then I'm going to use what they're going to give me up here, so to the h power to work it through. So I started with 35 yeast cells, I tripled each hour. All right. Dustin used f of x equals 15,499 times 1.08 to the x power to show how the balance of his student loan increased over time. So A, I know is the first part. B is inside there. So my A value is 15,499. My B value is 1.08 for that. Now, we know A, again, is my initial value. So if I'm looking at the balance of his student loan, that means his initial balance or initial amount is $15,499. Now the 1.08, that is looking at the percent increase or percent decrease. So would this be increasing every time or decreasing every time? It's going to be increasing. So I also know that I want to get it to a percentage. Right now it's in a decimal. I want to figure out what that is as a percentage. So if I take in my calculator and I do 1.08 times 100 to get it to percentage, I get 108%. Or 100 plus 8%. So most likely what they're going to do is how it increased by 8%. So we can say his balance increased by 8%, and it says time, so we're just going to give it per year. Another quick little thing to note is when you have an exponential function, it's increasing by a percentage or decreasing by a percentage. Whereas when you have linear, that's when it's increasing by a set amount or decreasing by a set amount. So since I know it's exponential, I knew I had to have that increase by percentage part to that. On 74 through 78, we're all referencing this one little equation. So I still have y equals 3/4 times 1/2 to the x power. So again, I want to think about this as a b to the x power. So my a value is 3/4. My b value is 1/2. I want to know about the asymptote. I want to know the equation for the asymptote. I want to know the y-intercept, and I want to know if it's growth or decay. So my y-intercept talks about my a value, and I know y-intercept is 0 something, and I know it's 0a. So since my a value was 3/4, here this is 0 3/4 or 0.75. Growth and decay is going to look at this rate. So that's be the same thing. So is that if growth is when the b value is greater than 1, and decay is when your b value is between 0 and 1. So would this be growth or decay? It's going to be decay. So last but not least, this asymptote. This is when I'm going to pull out my calculator and look at it. So I'm going to throw this into y equals, clear all this other stuff out first. And I've got 3/4, and then parentheses, 1/2. And then I want to make sure I'm raising this to the x power. So I'm going to do caret and then x. So when I go to graph this, mine's all poor than it. This actually helps me. So it's leveling out. So I think about it as a slide. So it goes whee, and it gets super close to 0. I go back to where it looks standard. Again, I can see it going whee, and I can even see here how it's decay. I can see that it's crossing way low on that y-intercept. And if I wanted to see the y-intercept, I could also go to the table and see that it starts at 0 3/4. And then I can know that it is a horizontal asymptote. We won't deal with vertical asymptotes in Algebra 1. And my equation, since it's horizontal, it would be hoi, so y equals 0. All right. Which type of relationship would represent the following data? So I want to see if it's linear, quadratic, or exponential. Okay, so if I'm trying to determine which one it is, this is when I've got to be able to look at the r-squared. So I have to be able to turn on diagnostics. So there are two ways to turn on diagnostics. The way that I like to do it might not be the way that you've seen it with your teacher, but if you go to mode and you go all the way down to the bottom, or I just click up to hit to the very bottom of it, if you look right here, it says Stat Diagnostics. I'm going to the arrow up and turn it on. The other way is to do second 0, go alpha D, and go all the way down to diagnostics on, and then click enter twice. So now that it's on, I need to be able to go from a table over, so I'm going to use stat, enter. I'm going to write over these. So I got -1, 0, 1, 2. Notice I'm using the entire table. We want to make sure we have the most accurate data possible whenever we're doing this. Okay, so once I get it in, I'm going to go check each one. Stat, calc. I want linear, so 4. Calculate all the way down. R-squared is 8.0. I'm just going to put that next to it so I can see it. So for this one, I have r-squared as 0.80. All right. Oh, I'm sorry, r-squared And I'm gonna go back. Okay, it's 0.09. All right, all right. And then we're going back to stack, back to calc, but this time I'm going to try quadratic. So I'm gonna go to 5. All the way down. And this time R squared is 0.89, 0.984. All right, then check the last one. Stat, calc. Go to 0 for exponential. All the way down. Oh, that didn't work. Something's wrong, weird on that. So what didn't it like? Stat, calc, 0, L1, L2, all the way down. Well, we're gonna say it's that. All right, so I'm guessing. Let me check another way. So another way to weirdly check, just to make sure, so let's make sure I didn't mess anything up. Let's go back to my table. -1, 0, 1, 2, -1.5, 6, 24, 96. Nope, that should be it. Okay. So if you check to see if you divide each one, if you get the same number, then it's exponential. Okay, so then let's see. 24 divided by 6 and 6 divided by -1.5. Oh, so that either needs to be a positive 1.5 or not. My guess is this should be a positive 1.5 or it's quadratic. But we're going to go with it's exponential because I'm pretty positive that it is. So that's a mistake on our part. Oops, my bad. Change it. I'll make sure it's changed for your teacher, so you'll probably get that beforehand. All right, last one for this video. Table is an exponential function. Ooh, it's telling me exponential. Is shown, which could be described. Oh, we just talked about this. Remember, exponential increases by a percentage each time. Linear would increase or decrease by a certain amount each time. So I already know that B and D are out because it's told me it's exponential, so it has to go by a percentage. And then, so I can avoid the calculator if you want to, I can see how C and A, one of them's increase and one of them's decrease. So when I look at those Y values, am I increasing or am I decreasing? I'm increasing. So it has to be A. The other thing to do is to go to StatCalc and use 0 to find out what that exponential function would be. And you would have to look at your B value to be able to answer the question. All right, guys, I'll see you for the next set.